Hi everyone, in this video we are going to see how to work in Homer software. Homer is a micropower optimization model which simplifies the task of evaluating design of both off-grid and grid-connected power systems for a variety of applications. When you design a power system, you must make many decisions about the configuration of a system. What component does it make sense to include in the system design? How many and what size of each component should you use? The large number of technology options and the variations in the technology cost and availability of energy resources makes these decisions difficult. Homer's optimization and sensitivity analysis algorithm make it easier to evaluate the many possible system configurations. Homer can be operated or work in three ways. One is for simulation, second is for optimization, and third is for sensitivity analysis. Simulation. Homer simulates the operation of a system by making energy balance calculations for each of every hour in an year. For each hour, Homer compares the electric and thermal demand in the hour to the energy that the system can supply in that hour and calculates the flow of energy to and from each component of the system. For system that includes batteries or fuel power generators, Homer also decides for each hour how to operate the generators and whether to charge or discharge the batteries. Homer performs these energy balance calculations for each system configurations that you want to consider. It then determines whether a configuration is feasible, that is, whether it can meet the electric demand under the conditions that you specify, and estimates the cost of installing and operating the system over the lifetime of the project. The system cost calculation accounts for costs such as capital, replacement, operation and maintenance, fuel and interest. Optimization. After simulating all of the possible system configurations, Homer displays a list of configurations sorted by net present cost, sometimes it called as life cycle cost, that you can use to compare the system design options. Sensitivity analysis. When you define sensitivity variables as input, Homer repeats the optimization process for each sensitivity variable that you specify. For example, if you define wind speed as a sensitivity variable, Homer will simulate system configurations for the range of wind speeds that you specify. This is the main window of the Homer software. In this, The equipments can be added or removed by clicking add or remove button. Add or remove button equipments but window will consist of loads components like primary load 1, 2, deferrable load, thermal load and hydrogen loads. Components like PV, that is solar panels, wind turbines, hydro, converters, electrolyzers, hydro tank, reformers. And we have a set of generators up to 10 generators and batteries up to 10 batteries. We can connect a system to the grid and we can find the simulation and optimization results, or we can work in the standalone, or even we can compare the standalone system to the grid extensions. For this we have to just, if you want the system to get grid connected, you just click the option for grid connected, and if you want to compare the standalone system to the grid connection, you just click for standalone, compare standalone system to the grid connection, grid extensions. By clicking this, you can choose which one you need and which is feasible for your design. And loads, you can just click primary load, any number of loads can be selected, and components, either it may be a solar panels or wind turbines or hydro converters. We need, when we use solar panels, we need converters for converting DC into AC. Normally solar panels will produce an DC voltage which have to be converted into AC using a converter, that is inverters. And we can choose a generators and battery for storing the energy from the solar panels. Now let us design a simple project using this Homer software. Just click a primary load, PV panel and wind turbine and converter, and if you want a battery, you just connect a battery and one generator. Just click OK. All the elements will be displayed here. This is the place where we can find the components which we have chosen for our project, and below the components is the resources which we need to specify for sensitivity analysis. For example, solar, we are using a solar panel, so there will be a solar resources. We are using a wind turbine, so there will be a wind resources. Diesel for generator, economics, system control, emission and constraints. If there is any data to be scaled or any data have to be included, it is shown in the warning symbol. And the document represents the author and the notes. If you want to if you want to mention your name or the project name or any of the project related notes, you can specify here. Just and you can choose here. Right side to the component space is we can see a calculate button. After giving the specified required values for the load converter, PV panel, wind turbine, and battery, you just click calculate. And you will be getting sensitivity result and optimization results. These results we can get the both optimization result and the sensitivity result by the respective tabs.